I'm Lucinda, I work on the HipSci project here at CGAP. All of the iPSC lines for the HipSci project are made here at the Wellcome Trust Sanger Institute. In this video, we aim to demonstrate how we culture feeder-free iPSC lines. As a point of reference, I would recommend you print out the SOP that accompanies this video. We will be covering how to thaw feeder-free human iPSCs, how to culture and passage feeder-free human iPSCs, and how to cryopreserve feeder-free human iPSCs. The first thing you need to ensure is that you have all of these necessary materials, reagents, and equipment to hand. We strongly recommend that you thaw HipSci lines in accordance with our SOP. Make a master bank of the lines as soon as possible to avoid losing any of your lines. Once your lines are thawed and established, after about 1 to 2 passages, you can consider transitioning them to a different culture system. iPS cells may not respond well to any change, so please keep a maintenance plate of the original culture alongside your new method. Before you thaw cells, prepare a stock of E8 medium plus rock by adding 10 millimolar rock to an aliquot of E8 to a final concentration of 10 micromolar. That's a 1 in 1000 dilution, and allow to warm to room temperature. Partially thaw the frozen vial of iPS cells at 37 degrees using a water bath until there are small ice crystals remaining. Dry and spray the vial with 70% ethanol before placing in the culture hood. Add 1 ml of E8 plus rock solution dropwise into the cryovial with a 5 ml stripette. Then gently collect and transfer the entire cell suspension into a 15 ml falcon tube. Add 8 ml of E8 plus rock solution to the cell suspension. Centrifuge at 120 G for 3 minutes. During centrifugation, aspirate vitronectin from 1 well of a pre-prepared 6-well coated culture plate. Aspirate supernatant from the cell pellet, and using a 5 ml stripette, gently resuspend in 2 ml of E8 plus rock solution. Pipette gently up and down once to mix together. Transfer cell suspension into the prepared well of a 6-well plate. Agitate plate gently within a tissue culture incubator set at 37 degrees and 5% CO2 to ensure an even distribution of cells across the well. Check cell attachment under a phase contrast microscope after 24 hours. If the attachment is good, change medium to 2 ml of E8. If there are more cells floating than attached, top up with 1 ml freshly made E8 plus rock solution. It is good practice to observe your iPSCs under a phase contrast microscope daily. We are looking for iPSC-like morphology, confluence, and the presence of any differentiated cells. To passage, aspirate spent medium from wells to be passaged. Wash wells with 2 ml of DPBS per well and aspirate. Add 1 ml of 0.5 millimolar E to TA solution to the wells to be passaged. Rock plate to cover the whole well surface. Incubate at room temperature for 4 to 8 minutes, observing under phase contrast microscopy until the colonies display bright halos around the edges and small holes start to appear throughout. Aspirate the 0.5 millimolar E to TA by tilting the plate slightly forward to collect the E to TA at the bottom edge of the wells. Take care as the cells are loosely attached. Immediately add 2 ml of complete E8 medium to the wells. Using this 2 ml of media, gently wash the cells from the plate by pipetting the media around the well. Approximately 3 times, using a 5 ml or 10 ml stripette. This should dislodge cell clusters without dislodging any differentiated cells. Do not over-pipette the cells, as this will result in single cells rather than cell clusters. It is possible that occasionally not all the cells will lift. There may be rings left behind on the plate. Now dilute the cell suspension with complete E8 medium in a 15 or 50 ml falcon tube at an appropriate cell density in accordance with your desired split ratio. Aspirate vitronectin solution from pre-prepared coated 6-well plates. Seed cell solution into as many wells as required. Agitate plate gently within a tissue culture incubator set at 37 degrees and 5% CO2 to ensure even distribution of cells across the well. Before attempting to freeze down cells, please make sure your colonies are large enough to freeze. This should be approximately 4 to 5 days after passaging, when cells are approximately 70 to 80% confluent. A confluent well of a 6-well plate will have enough cells to generate 5 to 6 frozen vials per well. Prepare appropriate volume of freeze medium to freeze 1 ml cell suspension per vial. Prepare a cell freezing container. If required, make sure to use the appropriate volume of replenished isopropanol and store at 4 degrees until use. Aspirate spent medium and wash wells with 2 ml of DPBS per well. Aspirate DPBS and add 1 ml of 0.5 millimolar E/TA solution to wells. Rock plate to cover the whole well surface. Incubate at room temperature for 4 to 8 minutes, observing under phase contrast microscopy until colonies display bright halos around the edge and small holes start to appear throughout the colonies. Aspirate the 0.5 millimolar E/TA by tilting the plate forward slightly to collect the E/TA at the bottom edge of the wells. Take care as the cells are loosely attached. Immediately add 2 ml of complete E8 medium to the wells. Using this 2 ml of medium, gently wash the cells from the plate by pipetting the medium around the well, approximately 3 times, using a 5 ml or 10 ml stripette. This should dislodge cell clusters without dislodging any differentiated cells. Do not over-pipette the cells, as this will result in single cells rather than cell clusters. Pool cell suspension into a 15 or 50 ml falcon tube and centrifuge at 120 G for 1 minute. Aspirate the supernatant and tap the falcon tube to dislodge the compacted pellet. Resuspend in an appropriate volume of freezing medium, giving a total volume of 1 ml per cryovial. Dispense 1 ml of cell colony suspension into each cryovial and seal tightly. Immediately place the cryovials in a pre-chilled cell freezing container. Transfer the container into a -80 freezer. Allow the cells to remain at -80 overnight, or between 16 and 36 hours. Once frozen, transfer the cells on dry ice into an ultra-low temperature storage vessel, LN2 or a -150 degree freezer.